Hello friends, I'm solving a problem from design of machine element, and in that design of shaft. The concept is design of shaft. So here is the problem definition, and a 100 circular shaft is given. Okay, and we have to compare the torque transmitted by the solid shaft and torque transmitted by the hollow shaft. If the solid shaft is replaced in the place of hollow shaft, or vice versa, what is the amount of torque transmitted varying, that has to be calculated. Okay. Here the wall thickness of this hollow shaft is given. This is an illustration sketch for you. So the wall thickness of a hollow shaft is given. So this is outside diameter, this is inside diameter, and this will be the thickness, and the thickness given is on the one side. So next opposite side also we have to consider while calculating this kind of problem. So one side it will be 10 mm and two sides it will be 20 mm. Okay. So and the condition also given is diameter of the solid shaft is equal to the outside diameter of the hollow shaft, or outside diameter of the hollow shaft is equal to the diameter of the solid shaft, that is 100 mm. So we have to compare the torque now. Initially we will start with the solid shaft. The equation given is tau equal to 16t by pi d cube. Use your design data handbook K. Mahadevan and Balveer Reddy. So when you substitute this diameter value, that is 100 mm, you will get this value. Okay, keep t as it is because we don't know the value of torque. We have to compare the torque now. Okay, so suffix s is for solid shaft. Okay, fine. The next, maximum shear stress of hollow shaft. So before using the equation we will find the diameter of the inside shaft. Okay, so diameter of the outside shaft of this hollow shaft is equal to the diameter of solid shaft. So this will be 100 mm. So and the equation is outside diameter is equal to inside diameter plus 2 into thickness 1 2, that is 2t. So let's make necessary arrangement, and di is equal to 100 minus 2 into 10. So that will be inside diameter is 80 mm. And next, here the equation for hollow shaft, tau h, that is hollow, is equal to 16t by pi d cube into 1 by 1 minus k to the power 4. So here k is the ratio of inside to outside diameter, that is di by do. So in the place of k we will substitute di by do, and we will take this after opening the bracket we will get di to the power 4 by do to the power 4. So and here this one, and taking do to the power 4 as denominator, here multiply this d to the power 0, sorry, do to the power 4 minus di to the power 4. Here it was do to the power 4 earlier, but now I will take it to the numerator, that will be do to the power 4, and this term as it is. Next, here d to the power 4 is there and d to the power 3, so I will cut this d to the power 3 gone, and this 3 gone, this do remains here. Here do remains, outside diameter remains, here it will be 1. Okay, so now outside diameter of the hollow shaft is equal to the diameter of the solid shaft. So therefore this is 100, do is 100, and the di value we have found out here, di is equal to 80 mm. So therefore we'll get this value, tau hollow shaft, shear stress of hollow shaft is equal to 8.626 into 10 to the power minus 6 into torque transmitted, that is t suffix h. So now according to the given condition, the shear strength of the hollow shaft and the solid shaft both are same. Okay, therefore tau s equal to tau h. Here tau s value we have, here we have tau s, and here tau h. So compare, and you will get th is equal to 0.59 ts. That means the torque transmitted by hollow shaft is equal to 0.5 times the solid shaft. That is the answer or comparison for this problem.